Perfect. I'm going to speak English. I will try to be as clear as possible, and I'm sure you will understand everything. So my presentation would be JGrassTools, and here you read the Horton machine for data analysis to help scientists, and not only. I will explain in very few seconds why you see Horton machine there and not JGrassTools. I'm Andrea Antonello. I'm a founder of a small company that does hydrology and geomorphology in Italy. It's called Hydrologist, and we are part of the gvSIG association. I'm as well a charter member of OSGeo and, in general, a open source, free and open source software advocate. I work on a digital field mapping tool called GeoPaparazzi and on the Horton machine project and on migrating all these tools inside gvSIG. To understand why there is Horton machine written, you should first know what JGrassTools is. JGrassTools is a project that started back in 2002. I had been working for a couple of years on the GRASS project, which is a very big and important GIS, open source GIS project. And we started to create a user interface in Java for this project. And we were also bringing all the hydrological and geomorphological modules of our university into open source GIS. And this is how JGrassTools started. And over the years, we tried to be standalone. We then joined the project UDIG. And around 2015, we entered the gvSIG project and started to work on migrating our tools inside gvSIG. So this is the only slide that will very quickly explain why Horton machine. In principle, the project was called Horton machine. Then, due to the bonding to GRASS, we started to call ourselves JGrassTools. And in recent years, there have been lots of discussions. So since we now start to really make our first releases in gvSIG, and it's going to be a bit more important, we went back to our original name, Horton machine, so that we do not create confusion. So that's all about it. What is the Horton machine inside gvSIG? If you install the plugins, you will get a new menu, which is H machine, and you will have some tools in it. The special toolbox, which when you open it, will open a window with a lot of modules that work on several thematics, which I will explain you, and you can insert your parameter and run your modules. Once the module finished, it will load it in your map view. The nice thing about this, if you're a scientist, you will mostly work with huge data and do a lot of tests. And what happened to me in the past is that the computer freezes when you use loads of data. Here you have the possibility to say, use just that memory and otherwise die. And this is nice because you can run modules and do other work in the meanwhile. So the modules are divided by the original huge package, the Horton machine, which is a package about geomorphological analysis, hydrological analysis, and a little bit of hydraulics. We have some raster and vector processing, which usually is used to prepare the data for the bigger modules. We have some support for mobile, for the GeoPaparazzi mobile application. And then there is the latest module that we developed with the University of Bolzano, which is called RASTER. It's the LiDAR Empowered Science Toolbox open source and works on LiDAR data, obviously. So the Horton machine modules are, if you are in hydrology, geomorphology, it's something you've heard 1,000 times, drainage direction, pit filling, total contributing area, extraction of the network, extraction of the watershed, curvature, slope, everything you need to identify through hydrological and geomorphological attributes your basin. Then you have some statistical tools. Everybody knows, working in hydrology and geomorphology, everybody knows the kriging modules, a geostatistical interpolator. But often for certain modules, for example, for water scarcity modules, you will need also to interpolate temperature, humidity, wind, pressure, and those are not interpolated in a geostatistical way, but along the vertical. So we have a module that's called JAMI, which is just another meta interpolator, and it will help you to do this kind of interpolation. Then the big modules come. PEAKFLOW, which is used to evaluate the maximum discharge, to work on analysis on flooding. Some VENANT, which implements a simple one-dimensional hydraulic model, which allows also for inflow and outtakes, and is based completely on GIS data. Inside inside the Spatial Toolbox, you also have the possibility to prepare your data for HECRAS. If you use HECRAS and you want to work on your river and elevation model, with these two information, it prepares the data to be used in HECRAS. Then we have a hill slope stability model, which is called SHALSTAB. And if you're working on debris flow, there is a module for you which works on analyzing the triggering, the propagation along the network, and also the final propagation on the alluvial fan. In LASTER, we have some tools that work on LiDAR. Some to, for example, do the first preparation of the data, which might be preparation of the DTM, starting from LiDAR data, through adaptive TIN. We have a simple extraction of buildings from a LiDAR data set. Single tree extraction, and this is on what we have focused most, extraction of trees through the single tree approach. So we extract the single tree position and height. And these modules work both on LiDAR but also on raster data if you have just that kind of data. A part of the Spatial Toolbox, we have another tool that is called the raster map calculator, or shortly MapCalc. If you're a hydrologist and morphologist, you need a lot of raster processing. It's less shapefiles, it's more raster data. The MapCalc tool is something where you will say, okay, I would like to have my raster data only between 1,000 and 1,300 meters and only those that look south. If you have an elevation model and a map of aspect, which gives you the azimuth of every pixel, you can just use an equation like this, a condition like this, where you say it's very simple to understand, less than and big, larger than, and the map calculator. Map calculator is a window inside which you can put your formula, you can give the list of rasters to be used, and as you can see in the resulting map, it will show you it will do a small calculation. It's kind of a middle way to advanced GIS and scripting. This is smaller than scripting. You don't need to learn anything. There are tools for digital field mapping to prepare your data and to import your data from GeoPaparazzi. It's kind of beyond the scope of this presentation, so I just leave it to this slide. And the same goes for the EPANET. EPANET is a powerful software to do water supply system management and analysis and design. And there are a lot of presentations already for the use of EPANET in gvSIG. And so I will stop here with this. I want to show you in this presentation the tools we use, and this is where it comes. Small tools we use when you are a scientist, when you kind of also write modules. So the last sub-menu has some tools and utilities that we were a little missing in gvSIG. So the first is a very simple tool. It's a position information tool. Often I have to click and have a look where my watershed extraction will take place. And this tool also has a small component to do for you the reprojection of the coordinate. Then there is the well-known text geometry tool. This tool gives you the possibility to select a geometry in a layer, and you can copy out that feature, the geometry of that feature, as well-known text. Well-known text is a simplified representation in text of your geometry. And with other tools, you can then investigate the geometry. This is useful if you are writing a module and some information that you print out in the middle need to be visualized in your GIS. So here you can also take a well-known text geometry, put it in there, and add it to the current layer. So it's kind of a runtime layer editing where you can continuously add your information or read your information. One tool I've been missing, and in the latest version of gvSIG, it's almost taken care of, is the projection file. For me, it's always been extremely important to have the data with the projection information. Now, gvSIG reads, if you load a shapefile with a projection file, it reads that information. For some kind of data, it's still not there, so you have the possibility to add that projection file with a simple click. And maybe if you have to add Bursa-Wolf parameters or some changes to the original projection, this can also be very useful to you. One tool I really need every time, and I've never seen it, it's the feature browser tool. I sometimes have to have a look at all the features in a layer. Maybe you have 1,000 features and it will take you the whole day. And you have a look at it and then you have to go for a coffee and you come back half an hour and you say, oh, did I make this feature or not? So this tool here simply opens up. You select a layer and then you can do next, 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 and previous. And it will zoom to each feature and show you the information of each feature. You go away half an hour, you come back, it's still exactly there, and you're sure you're not missing any feature at all. As I said, these are very simple tools, and they might be of use or not. They are of use for me, and I hope to someone else also. The raster styler, this is one of the things that is available in a way that I didn't find very useful. You can style a raster map, indeed, and you can select color tables, but you will have a legend which is not exactly readable because you have a lot of entries, and if you start at the beginning, I started to remove and try to change the color, but it was taking more time. So we added a raster styler that would give the possibility, for example, the map of aspect, which is simply the degrees of azimuth. It's between 0 and 360. And to have this sensation of 3D, usually you style it from 0 to 180, white, black, and 180, 360, black, white again. So it's just 3 rules. And the raster styler gives you the possibility to do this. Have some pre-compiled raster maps, well-known raster maps like aspect, elevation, flow directions, and it will give you the possibility also to use a little bit of transparency. So if you, for example, do this for aspect and then add also an elevation model, you will get a very nice sensation of a simplified 3D model. And in this case, you can also define, this is important for the legend, if you have double maps, you will have, you can format the decimals. For maps that contain categories, you need not numbers but labels. So this gives you the possibility, for example, in the map of flow direction, to style your map and have labels like east, north, south, and what you really need to know about that. Stable, unstable in the case of shall stop. So it labels by category your raster maps. Another tool we had was to solve the problem that sometimes you have to analyze a small portion of a big map. And this is what it is. You look at it and say, okay, it's all the same, right? But it's not. The problem is that huge maps create huge color tables interpolated on the big map, so small parts will look the same. We kind of need a local color table. And this is a tool, if you right-click on the raster, it's called Raster Graphics View. It gives you the possibility to visualize temporarily a local color table. So this gives more information of what's happening there. And if you are working on some modules and you need to know locally what values you have, you can also say, please show me also the numbers of the raster in the cells. And maybe you're working on a module and you're trying to understand why your module doesn't exactly do what you're doing in this row and column. Then you can also say, please show me the row and the column in the raster of this raster, or show me both. If you then are a hydrologist or a geomorphologist, it will be very handy to know that you can also enable a visualization of the steepest direction. So it's kind of a simplified version of the flow direction. Behind the flow direction modules, there is a lot of more science, but already knowing the steepest direction, and if there are points, if you see the red dots, these are points, are pits, where the cell is deeper than all the cells around it. So this is a temporarily very simplified version that can help you to understand small portions of your raster. The last tool, and I think I'm in time.
3 minutes.
3 minutes, perfect. I'm almost done. So the last tool I want to show you is the raster values copy. It happens to me often in the same scenario. I want to know what values are there, and then I would like to know why my module I'm developing doesn't work, and I don't want to use it on the whole raster, which always takes 5 minutes. I want to do it on a small portion. The raster values copy, still right-clicking on the raster, you get it in the main menu, in the context menu. You can zoom to a region, you do raster value copy, and what it does, it extracts the visible portion of the raster map as every ASCII grid. So you have it in copy, you open a text editor, you do just paste, and save it. It will be a raster, and you can add it or use it, add it back in the view, or use it in your module. This is very, very handy to create very quickly small portions, to analyze small portions on a computational way in your raster maps. I think that's all. I'll leave you to the home page, which is now Horton Machine. If you go on JGrassTools, it will direct you to Horton Machine anyways. There is a mailing list where you can help you out. There are several presentations on the SlideShare link about JGrassTools, about EPANET, all the things we've done in gvSIG with the Horton Machine. Yeah, I think that's everything. Thanks for attention.